Halfway up a quarry wall in Aswan, there's a scoop cut into solid granite. Not a crack, not a chip. A smooth, curved gouge, the kind of shape you would expect from a machine tool, pressed into one of the hardest natural stones on Earth, thousands of years before anyone on the planet had invented one. There are hundreds of these scoops scattered across the quarry. Some sit in open, easy-to-reach stretches of rock, exactly where you would expect ancient workers to have been swinging hand tools. Others do not. Some appear tucked beneath blocks that were never fully removed, in gaps too narrow for a person to kneel in, at angles no human arm could reasonably W-ing a hammer through. For over a century, archaeologists have had an answer for how this quarry was cut. And for just as long, a smaller group of people standing in front of these particular marks has quietly not believed it. To understand why this particular quarry keeps generating controversy, it helps to understand what it actually was. Aswan sits at Egypt's southern edge, where a band of exceptionally hard, pink-toned granite runs close to the surface of the earth. For thousands of years, this was the source stone for some of ancient Egypt's most ambitious monuments: obelisks bound for Karnak and Luxor, colossal statues, sarcophagi, and temple elements, all extracted from this one stretch of desert and floated down the Nile to wherever the pharaoh's builders needed them. Granite is not an easy material to work. It's an igneous rock, formed under enormous heat and pressure, made of interlocking crystals of quartz, feldspar, and mica that give it a hardness most ancient tools struggle to touch. Copper, the primary metal available to Old and Middle Kingdom Egypt, is far too soft to cut granite directly. A copper chisel pressed against granite simply blunts. Whatever method was used had to work around that basic material limitation, not through it. This year, that disagreement went viral again, because someone pointed an AI system at high-resolution images of the marks and asked it a simple question. Does this look like it was made by hand? The answer that circulated online was blunt. Size variation under 5%, spacing consistent to within 3%. A constant curvature radius across scoop after scoop. A uniform angle of approach, as if every cut had been guided by the same fixed toolpath. According to the posts sharing these results, that kind of consistency does not happen when a person is swinging a stone by hand, over and over for hours, across a surface as unforgiving as granite. It happens when a process is mechanically repeated, guided, controlled, uniform. The claims spread fast. Artificial intelligence had just done what a century of archaeology hadn't. It had measured the marks objectively, without assumption, without tradition, and the numbers didn't match the story we'd been told. Before going further, it's worth being precise about what that claim actually is and what it isn't. There is no published, peer-reviewed study behind these numbers. No research institution has put its name on this analysis. What exists is a set of claims, shared and reshared across social media, attributed to an AI system examining images of the quarry. That does not mean the underlying observation is worthless. The marks in question are real. They are physically strange, and people have been photographing and arguing about them for decades. But it does mean the specific statistics, the 5%, the 3%, the uniform angle of approach, should be treated as an unverified claim, not an established scientific finding. This is a story about a mystery, and about a controversial new attempt to quantify it. It is not a story about a settled discovery. So, set the viral claim aside for a moment, and look at what the quarry itself has already told archaeologists. Because the real history here is stranger and more interesting than most people realize. The site is called the Unfinished Obelisk, and it is exactly what it sounds like. A single enormous obelisk over 40 meters long, still attached to the bedrock it was carved from, abandoned partway through construction after cracks appeared in the granite. It was rediscovered and cleared of sand in the early 20th century, and what it revealed was not a mystery but a snapshot, an entire quarrying operation frozen mid-process, tools and all. Scattered across the site, archaeologists found thousands of dolerite pounders, fist-sized, extremely hard stones, harder than the granite itself, used as hammers. The standard account, taught for generations, is straightforward. Teams of workers repeatedly struck the granite surface with these pounders, over and over, pulverizing it into powder and fragments, slowly carving out trenches around the shape of the obelisk they wanted to free from the surrounding rock. Once the trenches were deep enough, the final separation from the bedrock beneath was achieved by a different method entirely. Cutting a line of small cavities into the stone, packing them with dry wooden wedges, then soaking the wedges with water. As the wood absorbed the water and expanded, it split the granite along a controlled line. The same basic principles stonemasons still use today with modern splitting wedges. That's the mechanism. Simple materials, patient repetition, and a clever use of a wooden wedge's ability to expand. No metal blade required, no hidden machine, no lost technology, just an enormous amount of coordinated human labor. The site backs this up with more than just tools lying in the sand. Archaeologists working the unfinished obelisk in the 1920s and 1930s mapped tool marks across the trench walls in careful detail, and what they found was not chaos, but organization. Repeating patterns of pounding consistent with teams of workers assigned to specific sections, working under what looks like experienced supervision. Hieroglyphic inscriptions found near the site name quarry supervisors and record dates, the bureaucratic residue of a large coordinated labor operation rather than a scattered improvised effort. Worn pathways between extraction points and tool staging areas show where workers moved back and forth day after day. It's a genuinely detailed administrative and physical record, one of the clearest windows anywhere in the archaeological world into how a large ancient construction project was actually organized and run. Which brings up the first real problem with the Dolerite explanation. And it isn't mystical, it's practical. The numbers don't obviously support the amount of granite that was actually removed. Researchers who traveled to Aswan in 2022 ran a direct experiment to settle the question. Using a genuine Dolerite pounder on an open granite surface near the unfinished obelisk, they measured, through careful photogrammetric scanning, exactly how much stone a person could remove per hour by hand. The result? Roughly 216 cubic centimeters an hour. That's a volume smaller than a standard drinking glass. Per worker. Per hour. Earlier estimates from the 20th century, made by the Egyptologist Reginald Engelbach, had put the figure much higher, closer to 900 cubic centimeters an hour for a skilled worker. The newer, more carefully measured number suggests the older estimate was overly generous, and that removing granite by pounding alone was even slower and more brutal than previously assumed. Do the arithmetic on a monument the size of the unfinished obelisk, and the labor required becomes almost difficult to picture. Teams of workers, organized in shifts, pounding granite by hand for months just to cut the trenches around a single object, one that was never even finished. It is not that Dolerite pounding is impossible. Thousands of these pounders sitting in the sand prove it happened, at scale, repeatedly. It is that the pace was staggeringly slow, and that slowness is exactly the kind of detail that makes people start looking for something faster, hiding in the historical record. Sit with that slowness for a second, because it is the emotional engine of the entire mystery. 216 cubic centimeters an hour per worker is not a number that fits comfortably next to the scale of what Egypt actually built. The unfinished obelisk alone, had it been completed, would have weighed over 1,000 tons. Elsewhere in Egypt, granite blocks of similar scale were successfully quarried, moved, and set into temples that still stand today. At the pounding rate measured in 2022, extracting even a fraction of that stone by hand alone would require what amounts to an army of laborers working for an extended stretch of time on a single object, which is in fact roughly what the archaeological and administrative evidence suggests actually happened. Egypt had that kind of organized labor. State projects on this scale, backed by a centralized administration capable of feeding, housing, and directing thousands of workers over years, are well documented across multiple periods of Egyptian history. The math is brutal, but it isn't impossible. It simply requires accepting that the achievement was not fast or elegant. It was slow, grinding, and enormous, closer to a multi-year siege on a piece of rock than a clever trick. That search is where the mystery of the scoop marks really begins. The scoops are not the straight trench walls left by simple pounding. They are curved, concave depressions, and observers who have stood in front of them for years, engineers, tour guides, independent researchers, and more than a few professional archaeologists, describe the same unsettling impression. The marks look controlled in a way that repeated hand-up pounding shouldn't produce. Attempts to recreate them experimentally, striking granite by hand with a Dolerite pounder, tend to produce rough, irregular pockmarks, not the smooth, evenly curved scoops visible at the site. And there's a second detail that deepens the puzzle. Around many of these scoops, there isn't the volume of loose granite debris you would expect if the material had simply been pounded away and left in place. Some of the material appears to be missing from the immediate area, as if it had been carried off, or broken down by a process that didn't leave behind the same kind of debris pattern pounding wood. None of that proves a machine. But it is a real, physically documented inconsistency between the neatest textbook explanation and what the stone itself looks like up close. And it's the inconsistency that gave the AI analysis claim somewhere to land. It also isn't a new observation invented by social media. Engineers and researchers outside mainstream archaeology have been photographing and measuring these scoops for years, proposing their own explanations long before any AI got involved. One engineer, who has spent years studying ancient stoneworking sites, has suggested the marks could be consistent with some kind of pivoting cutting arm, a tool anchored at a fixed point and swept through an arc, which would naturally produce a constant curvature radius. Others have floated the idea of vibrational tools, or some form of controlled abrasive cutting rather than blunt force pounding. None of these proposals come with physical evidence of the tool itself. No fragments, no depictions in tomb art, no textual reference to anything matching the description. They are, in the language this investigation has been using throughout, claims and interpretations responding to a genuine anomaly, not confirmed mechanisms, but their existence shows that skepticism about the Pounders Alone story didn't start with a viral AI post. It has a longer, more serious history among people who spend their careers looking closely at ancient stonework, even if their proposed answers remain unproven. There's at least one other piece of physical evidence from the broader Aswan quarries that rarely makes it into either version of the story. The traditional one or the viral one. Alongside the diorite pounders, excavators have found traces of charcoal, ash, and burned mud brick at multiple points across the granite fields, not just around the unfinished obelisk. That points toward fire setting, a technique documented in stoneworking traditions around the ancient world, where fire is used to heat a rock surface, which is then rapidly cooled, often with water, causing the stone to fracture and weaken along controlled lines. It's a technique suited to breaking down hard rock faster than pounding alone. And it would leave exactly the kind of burn residue that keeps turning up at Aswan. Fire setting doesn't explain smooth, curved scoops on its own. But it does show that the story was never as simple as pounders and nothing else. Egyptian quarry workers appear to have combined multiple techniques, adapting method to material, exactly the kind of resourceful, layered engineering you'd expect from a civilization that quarried, moved, and erected stone at a scale still difficult to replicate today. This matters because it changes what explaining the scoop marks would actually require. It isn't a choice between one clean, singular method and a lost machine. It may be a choice between several known, physically evidenced ancient techniques used in combination: pounding for bulk removal, fire setting for weakening especially stubborn sections, water-expanded wedges for final separation, copper tools for fine detail work, and the marks representing some interaction between them that hasn't been fully reconstructed yet. A controlled fire set fracture, followed by cleanup pounding along the weakened line, could plausibly leave a smoother, more consistent scar than pounding raw, unweakened granite from a cold start. Nobody has published a study confirming that specific sequence produces Aswan's scoop shapes, but it's a hypothesis built entirely from techniques already proven to exist at the site, rather than one that requires inventing a machine with no physical trace. So where does that leave the viral claim? The specific, precise numbers reportedly generated by an AI examining the scoop marks? It leaves it in an unusual position, pointing at a real, still unresolved observational puzzle, while itself remaining unverified. An AI system trained to detect statistical regularity in images is very good at exactly that, finding patterns of size, spacing, and curvature across a large set of photographs, faster and more consistently than a human eye scanning the same rock face. If accurate, findings like unusually tight consistency in curvature or spacing would be a legitimate, useful data point, the kind of measurement archaeologists studying tool marks would want to have. The problem is that, if accurate, it's doing a great deal of work in that sentence. Without the underlying dataset, the exact images analyzed, the methodology used to measure spacing and angle of approach, and independent replication by people who study ancient stoneworking for a living, there is no way to confirm those percentages mean what the viral posts claim they mean. An AI model can also be shown selectively cropped or specially framed images, prompted toward a conclusion, or simply fed measurements without the archaeological context needed to interpret them correctly. Impressive-sounding statistics circulating without a visible method behind them are not proof. They're a claim wearing the costume of proof. That distinction matters, because it's the difference between two very different kinds of story. One story says, ancient Egyptians used simple Stone Age tools, worked with staggering patience and organization, and achieved something that still amazes engineers today. A genuinely impressive human achievement, fully explainable. No mystery required. The other story says they had access to a lost technology, perhaps machine-guided, that has since vanished from the historical record entirely, leaving behind only its fingerprints in the stone. The viral AI claim is being used, in most of the places sharing it, to argue for the second story. But strip away the unverified statistics, and what remains is something narrower and more honest. A real archaeological anomaly, the shape and consistency of certain quarry marks, that has not yet been fully explained by mainstream archaeology, sitting next to a claim about that anomaly that has not yet been verified by anyone outside the posts sharing it. Two unresolved things, standing side by side, easily mistaken for one resolved thing. It's worth asking, honestly, why an unverified AI claim spreads this fast in the first place. Part of the answer is that it plugs directly into a much older fascination, the idea that ancient civilizations, especially Egypt, achieved things modern people can't fully explain. and that mainstream archaeology has been too conservative, too committed to the simple story, to take the anomalies seriously. That instinct isn't irrational. Egyptian engineering really was extraordinary. Quarrying, transporting, and positioning stones weighing many tons, using tools made of stone, copper, wood, and rope, is a genuinely staggering achievement. Arguably more impressive, not less, if it really was done entirely without machines. The frustration with the simple story often isn't really about doubting the ancient Egyptians' capability. It's the opposite. It's a suspicion that the simple story undersells them. But there's a difference between saying, this achievement deserves more respect than a two-sentence textbook explanation, and saying, therefore an unverified statistic from an AI model must be treated as settled fact. The scoop marks deserve careful measurement, high-resolution imaging, and open, reproducible scientific analysis, the kind that gets published, checked, and argued over by specialists who can go stand in the quarry themselves. What they don't deserve is to have that legitimate curiosity short-circuited by a viral claim nobody can actually verify, dressed up as a done deal. Where does that leave the honest version of this story? The Dolerite pounder explanation is not wrong, it's incomplete. There's direct physical evidence, thousands of pounders, extensively documented trench walls, and now a carefully measured extraction rate. That hand pounding was a real primary method used at this quarry, however slow and labor-intensive. There is also direct physical evidence, burned residue consistent with fire setting, that at least one other technique was likely used to help break down the hardest sections of stone. And there is a genuine, still unexplained visual anomaly in the shape and consistency of certain scoop marks, one that has drawn serious attention from engineers and researchers long before any AI ever looked at a photograph of it. What there is not, currently, is a verified, peer-reviewed measurement confirming the specific statistical claims now circulating about those marks. And until that exists, AI revealed the method is a headline running well ahead of the evidence, which is, in its own way, the more interesting story. Not a secret machine hiding in the historical record, not a debunked conspiracy either. A live, physical puzzle, sitting in the open desert at Aswan, exactly where it's been for 4,000 years, waiting for someone with a verifiable method, a publishable data set, and no interest in going viral to finally explain it properly. Until that happens, the scoop marks stay exactly what they've always been. Proof that the people who built ancient Egypt's monuments left behind a record more complicated than either the simplest explanation or the flashiest claim wants to admit. Next time you see a headline claiming an AI has finally revealed an ancient mystery, ask the one question that cuts through almost all of them instantly. Where's the paper? If you had to bet, Dolerite and patience, a lost technique fire setting only hints at, or something nobody's identified yet, which way would you go? Say it in the comments.